So like many things in mathematics, an example is helpful. So let's talk about some examples of this idea and a couple of examples of what fails to satisfy this definition. So here are some examples of linear equations. So the following are linear. I'll just write this. The following equations are linear. So here's the first example. X plus 3y is equal to 7. So that's an example of a linear equation in two variables. And so this time I didn't go x1, x2 for my variables. I just went x and y. And remember what I said, if you only have a couple of variables, like 2 or 3 or 4 even, there's nothing wrong with just using different letters for each variables because there's not too many variables, so it doesn't get difficult to keep track of. So this is how I might write down a linear equation in two variables. And okay, well, what's the constant term? Start with that. That's the easiest thing to pick off. So ask yourself, what is the constant term of this linear equation? Okay, so, well, and if you aren't sure, just go back up here for reference. Remember what the constant term is? The constant term is c, and this referred to the number over on the right-hand side of the equation when something is written in this form. So in our case, in this example, our constant term is going to be 7. The coefficient of the variable y is 3, right? Because 3 is the number that's multiplied onto the y. And now, well, I've left x for last, but what is the coefficient of x? Is this a linear equation? If you go back up here, you'll notice that the x is supposed to have something multiplied onto it. But what is it in this case? It doesn't look like there's anything written in front of the x as a multiplier. Does that mean it doesn't have a multiplier? Actually, no. It's totally fine if nothing's written there, because all that means is that the coefficient of x is 1, because I could always just put a 1 there, right? 1 times x is the same thing as x. So if you don't actually see a coefficient written, that just means the coefficient of that variable is 1. So you won't always see them written for that reason. Okay, so that's an example of a linear equation in two variables. An example of a linear equation in three variables. The one I've used in the notes here is 1/2 x minus y plus 3z is equal to -1. That's a little bit messed up. That's an equal sign. So 1/2 x minus y plus 3z is equal to -1. So what's different here? Well, first, what's the coefficient of x? You can see that there's actually the fraction. 1/2 is the coefficient of x. The coefficient of z, well, that one's just written right here. It's 3. The constant term over on the right-hand side of the equation is -1. So in this case, our constant term is a negative number. That's okay. And notice actually here, this is the first time you've seen a negative sign in front of one of the variables. Does that mean it doesn't fit this form? Remember, this is the form of a linear equation. Notice that all of these operations between the terms are addition. And does that mean that this subtraction is not allowed? No, that's fine, because you can always just think of this as the following. Let me write this a little bit differently. Let me say or 1/2 x plus -1 times y plus 3z equals -1. Notice that those are the exact same equations, really. They describe the same relationships. This one has been written specifically so that there's an addition here between the two terms. Because if I add -1 times y, that's the exact same thing as just subtracting y. And that's the only thing that changed between these two equations. Right? So that's why if you see a negative in front of one of the terms, that's okay. That just means there's a negative attached to the coefficient. So in this case, the coefficient of y is actually -1. And if you're ever unsure just take the time to actually take the equation and rewrite it explicitly so that all the coefficients are clearly labeled. And for a quick little exercise, you could do that for the first one. Just rewrite this equation, x plus 3y equals 7. You just say, or 1 times x plus 3 times y is equal to 7. And if I write it in that fashion, I'm really making it very clear that there's actually a coefficient of x and it's equal to 1. So, but it is typical to just write it in this fashion. You'll see this written more often, but for the time being, if you want to get used to the idea that there's actually a coefficient here, you can just take the time to write it out explicitly as a 1. Just like this one, I can change that negative into a plus -1 times y. So that's another example of a linear equation. The next example, we'll do a linear equation in 4 variables. And this time I'm actually going to use the indexing strategy that was used up here. So this one has 4 variables. This one's going to be the following: x1 minus 2x2 minus 3x3 plus x4 is equal to 0. Okay, well, so we got 4 variables, x1, x2, x3, and x4. So n would be equal to 4 in this case. If you were to ask yourself what this n is, what this constant is, in this case, n is equal to 4 because there's 4 variables. It's the index of the very last variable. It's another way to think about it. Okay, so what's the constant term? It's over here. Right, on the right-hand side, it's a 0. The constant term in this case is 0. Some people might casually refer to this as just having no constant term, but it does have a constant term. It just happens to be 0. 0 is a perfectly suitable constant term. Okay, so what about the coefficients? The coefficient of x1, well, it's just going to be 1 since there's nothing written here. Same with x4. The coefficient of x4 is also positive 1. The coefficient of x2 is -2 because there's a minus here. Because there's a negative between the terms, that really -2 is the coefficient of x2, and -3 is the coefficient of x3. So those are 3 examples of linear equations. Let's look at a couple of examples of equations that are not linear, because not every equation is. So the following equations are not linear. Okay, so these ones were linear. These ones are not linear. Okay, so the first one, just going to adjust my camera here. So the first one we'll mention is x plus 3y squared is equal to 4. This is not linear. Why? Give yourself a few seconds to look at it and see if you can decide why it doesn't fit into the form of a linear equation. And the answer is because of this squared, right? Nowhere in the definition of a linear equation did we allow for exponents on the variables, right? That just simply wasn't allowed. And I'll just pull this down so we can see it in front of us again. Remember, a linear equation, you've got your variables. Each one of those variables, you're allowed to multiply it by a coefficient, a constant coefficient. And that was it, right? And then add the terms together. And just, you know what, let's just add this clear. To make it clear, the coefficients and the letter b, these must be constant. Since that wasn't officially said, I might have said it out loud, but I didn't write it down. It's worth writing down. The A1, A2 up to AN and the B, they're going to be constants all the time. They're not allowed to change. They certainly couldn't be, say, some expression involving the variables in your linear equation. Okay, so that's why this one is an example of an equation that's not linear. It's still an equation. There's nothing illegal about writing it down, but it just doesn't happen to be a linear equation. Okay, and then the next example, B, I'm going to write down sine of x plus y is equal to 0. So is that a linear equation in the variables x and y? Well, it's certainly an equation in the variables x and y, but it's not linear because we're not allowed to just apply a trigonometric function to one of the variables. That's not the same as multiplying by a constant coefficient. So it's because of this application of the sine function to the variable x that this equation is not a linear one. Again, just like in part A, it's still an equation. There's nothing wrong with it as an equation. It might be interesting to think about. It might be interesting to think about how to solve it, but it's not something that falls under the category of a linear equation. Okay, and one last example of an equation that's not linear is this next one. Oops. So example, I could probably fit it in right here just to save some space. So I've got x1, I'm going to put a square root on it, plus 2 x2 plus 3 x3 is equal to 1. So now the question is that a linear equation in the variables x1, x2, and x3? And again, it is an equation in x1, x2, and x3. It's got 3 variables, but there's a square root on one of the variables, and that's not allowed for in the definition of a linear equation. So for that reason, it's not linear. Now, if we change that square root to a cube root, or a fourth root, or a fifth root, or any radical symbol at all, it would still not be considered a linear equation because radicals are not allowed. So only terms separated by addition or subtraction where each term consists of one of your variables multiplied by a constant coefficient, and then you're allowed to have a constant term over on the other side of the equation. That's the most general way to write a linear equation. So anything you can't write in that form is not a linear equation.